I was talking to him. We were very lucky because early this morning they released a patch for Revit 2021 that fixed some bugs and make this presentation possible. So
Yep, exactly.
just on time. So I'm this presentation is being recorded. I just started a little bit delayed. Sorry, I skipped your presentation. But
Right.
Karan can start. Maybe you can talk a little bit about yourself, what you have been
Right,
doing,
sure.
and so people can know you better. And most people here is like I suppose everybody speaks English, so or understands English. So if you
Perfect.
want to make some questions, I suggest you to suggest people. I don't know what you prefer. If they just ask or wait
Sure.
for Q&A, up to you. You control the flow, please.
All right.
Okay.
So,
Now the
if
presentation is yours.
all right. Thank you, Fabio, for the introduction. My name is Karam Baki. As Fabio introduced, he also said we met in February. That was correct. I've shown him some pretty good stuff regarding the generative design. When it was actually called Fractal, then renamed to Refinery. That's a quick history of how it was made in Autodesk. So now it is called simply generative design. However, I have to mention that it is yet unstable, or let's say it has some serious bugs, and those bugs are being fixed, well, continuously. So in this presentation, actually in the early morning, there was something that actually prevented this presentation to be done, but we were actually lucky that the patch was out and it fixed some serious issues. So I actually don't mind if you ask me during the session, because I'm gonna do actually something from scratch. I'm gonna assume that most of you doesn't understand what is generative design or how does it work, or let's say have a very little idea of it. So basically speaking, Revit is parametric. We all understand that. Simply changing a wall height will actually make it parametric itself. It's all parameters. However, now if we like dig further into this, we will understand that if we change multiple parameters together, it'll be something called generative. However, we do understand that we can create families that drive other parameters together, but that's still called parametric. We can tell something now, we can actually call something generative when it does like hundreds or thousands of options automatically in the background and chooses the best options that we will target, or we will have our goals set into them. So we have actually multiple definitions. I'm not going to get into the details of the definitions, the naming. I'm going to just get into practical part. So I'm going to go ahead and launch Dynamo. I'm going to create a very simple example that'll actually make it very easy to you to understand how generative design works. I simply have an area, let's say something like this. Now I want a rectangle, a simple rectangle shape to be fitted in this area with the maximum area possible. So I want to fit a rectangle in this place. I'm not sure how will it work if I rotated it, increased the width and the height. I'm not sure how will it go, how is it going to be the final output, how is it going to be. So I'm going to let Dynamo do this for me, or let's say the generative design. You do have to understand something. Generative design is something exaggerated. It's not something magical. It just randomizes things in its background and tries to pick up the nearest goals we set. So let's start by simply making the input, or let's say preparing the input node. However, one final note before I get started: to actually be able to use the generative design in 2021, you have to have a separate license for it. That license is not purchased as the same license as Revit. This is from Autodesk side, just to let you know that. There's also a beta version called Refinery. You can access it from the beta Autodesk site, just to let you know. All right. So the first thing we need to know that we will have something called generative design in this add-ons place. Let me open it and go to selection and click on select multiple or select multiple family instances. So what's the difference from the select model elements in Dynamo? Well, Refinery team or generative design team created those selection input to be actually more compatible with the create study UI, or it's let's say it works better with it. So this is the first note that you'll have to understand. The selection nodes has to come from the generative design area. Right, so select multiple family instances. What am I going to select is simply those lines. They are not family instances, but we're going to consider them as a family, but select model elements, not family instance. Select multiple model elements. We're going to select them and finish. You will see the finish from the option bar. A quick note here, the select model elements that comes shipped with Dynamo behaves differently. It does not have the finish on the option bar, so this is something to notice. Yeah, the inconsistencies in Autodesk stuff, it's all right. So the select model elements, we have it here. Let's grab the curve, the element curves from them. This is very, very, very basic stuff yet. Let's flatten the list so we have a single list, or not multi-list as it is here. Next, let's get the start point of every one of these curves. Now we're gonna create a polygon. So if there was a curved line and you would want to create a polygon from it, I will recommend doing a segmentation to the line. There are some nodes that could be used for this. There's the synthesize package. There are segmentation by distances. You can use it, but I'm not going to include this case in here. So I have this polygon. Let me get its center. And this is the center of the polygon. All right. So the rectangle is going to be from that center. However, this center should change. I don't know where is the best center. So let me create a translate node that will translate this point in X and Y. I'm not very interested in the Z axis. Now the second node in the generative design workflow, your input in addition for the selection input has to be sliders. It cannot have a number as an input because it doesn't know what to guess. However, if you put a slider, it will know that I want it to guess the following values. However, I want them to be in the -2. So I'm going to write -100. But there's the third note. You or I don't recommend putting huge values because just imagine if the computer is going to guess randomized values, it's going to take lots of time. If you gave it some unreasonable big values for the case you are using here. So the whole thing here doesn't exceed like 30 meters, the whole thing here. So it's 22, so I'm going to actually make it -40, let's say, and +40, or 30 by 30. So this is a note to actually just keep in mind. Let me just say it 40 because the horizontal is, the vertical is more. All right. So the limit of the X translation, let me say it X translate, is -40 and 40. So if I put it here, I can see the point moving like that. I'm going to create another Y translate and here. So now I can actually make generative design toggle between the positions of these points. Now I'm going to create a rectangle. And this rectangle requires a plane. So I'm going to create a plane. So I'm not going to get deep into Dynamo stuff themselves. I'm just more interested in in explaining the generative design part of it. All right. So this is the plane. I've put it. And next, I'm going to have the width and length. So again, they're going to be number sliders. This is going to be the width, and this is going to be the length. So again, the same note applies. Do not insert a huge amount of numbers if you don't need them. Just for confirmation, can you still hear me?
Yes.
Correct.
Yes, very well.
Yeah.
All right, so what am I going to do now? I'm going to actually create, let's say, the same amount, like minus 40 and plus 40, because I'm not going to probably need more. Or let me just test it. All right, as you can see, so, there's no minus here. It's a width, just the positive. It would be minimum 1. So I would not need more than this. The same applies for the length. I will not need more than the 40 length, I guess. Yeah. So just take this as a note. All right. So of course this helps. These steps. If you made 0.01, Dynamo will have more options to mess with, which will require more time. You will have to remember. I think probably most of you know that Revit is really weak in processing. So it uses only one core. So you will have to make it optimized as much as possible. All right. Although I'm not sure if the generative design actually do parallel processing, but the general note applies. It is weak in processing. So the next thing we're going to do is rotating. I'm going to give it the ability to rotate by a base plane for the geometry, and the base plane is going to be the same plane, and the angle also has to be a slider. So this is going to be rotation angle. Let me just save the file. Any crashes happen, just testing stuff, or let's say generative test. Right, so the rotation angle, if you thought about this, I'm not going to need more than 90. So I'm going to go here, and as you can see here, let me just change stuff just to make sure that I'm not going to need anything else. I think 90 will actually cover everything up. So yeah, 90. However, based on my trial and errors, the rotation angle is kind of okay to give it a full 360, as it sometimes helps the randomization. Yeah, so it doesn't actually really makes difference here. So just for the sake of performance, I'm going to leave it as 90. So now we have the rotation ability, the width and the length, and the position of the center of that rectangle itself. So those are my actual variables that are going to change, or I'm not going to change them personally. Dynamo is going to do that and find the best solution within the rotation angle as well. Now I have finished my inputs. They are pretty straightforward and easy. But the thing is, you will have to score your goal. Now, when is the acceptable solution and when is the not acceptable solution? So the first goal is the area. I want it to have the most area possible. So I'm going to simply patch the rectangle. Just like that. I think it's pretty straightforward as well. And next, I'm going to actually report the area of this rectangle. So this is my first evaluation number. This area has to be the largest possible. Let me just colorize it something different. So this is a goal. And the other goal is the center of the rectangle, which is that point, or the middle point here we can see, has to intersect with the boundary or the space inside this boundary I have itself. So I'm going to patch again the whole these things. Let me just the polygon, the big polygon here. So this is another patched polygon, and I'm going to evaluate does intersect with the point, and it always must be yes with this point, the translated point. It always should be yes, because if it is out, then this is incorrect. After all, it's a computer. It's not a human. It can actually do this and tell me, oh, I gave you the biggest thing you want, and it'll be something stupid like that. There's just a little mistake here. I have patched the not rotated one. This is the one that should be patched. Yeah, so I'll have to force it to actually know when it is correct or not. So now it's incorrect. It's false. This is not correct. Let me just get it back where I want it to be. So this is now true. So this works. However, the next thing to evaluate is this patch, the rectangle itself, should not intersect with that polygon, with the initial polygon we created, with this one. It should not intersect with it. So the same patch would be evaluate the intersecting of this one, and it should return to false. All right, so if anybody has any questions regarding this, let me know now. Let me just decrease the width and the length so you can easily understand it more. Yeah. So let me hide the other stuff that might mess your head. This is the patch. This is the rectangle, not this one, the rotated rectangle. And this is the polygon. All right, and this is the point. So now it is accepted. Why? Because no, just a second. It doesn't intersect. No, just a second here. All right, let me just wrap it up. Where's the other patch? The other patch. Yeah. So now let me just wrap it up in my head. It is intersecting, and this one is intersecting.
Hi, Karam.
Yeah, there's a bit of an error, a logical error here. Let me just wrap it up. Yeah. What's the logical error in here? It should not actually intersect, not with the patch. I'm sorry. It should not intersect with the borders because it's always intersecting with the patch. So just let me fix this like this. All right, so let me wrap it up very quickly so everybody can be aligned with me. So when is this accepted? When is the rectangle accepted as something to continue guessing with? The midpoint of the rectangle has to intersect with this patch, the big patch, the boundary patch. The next, let's say, condition is that the wanted rectangle must not intersect with the borders, with those themselves. So if those two conditions happened, the rectangle is always inside these borders, and that's it, I guess. That's it. So you can ask me now.
No, that's it.
All right.
Okay, thanks.
If you have any question, let me know because I'm going to get into Python stuff now.
Okay. About the selecting nodes, we just able to use only generative design selecting nodes.
Well, some tests showed that I could use other selection nodes, but as I told you, things are not getting very recently consistent, so I'm sticking with this for now. And it has a percentage of 100% acceptance. You can select with other nodes, but I'd prefer using this. It's even more friendly, more user-friendly, as it has a finish in the option bar, unlike the other selection nodes in Dynamo. If you're asking about other selection, like choosing all category off or something
Yeah.
like that, it
Or
works. It works.
or Python nodes.
It works.
It works too.
It works, but you will figure out that it's useless because generative design is really specified to work with single cases. Imagine I'm working with multiple boundaries here. It's not going to be able to work because I will have to have x1 translate, x2 translate, x3 translate, y1,
Okay.
y2, y3 for each single boundary, and it's going to consume more time and it's going to be useless. If you
Okay.
just, if you just imagine that, it's not going to be very helpful. So
Thanks.
that's why I think generative design team made specific selection nodes, because they already understand that those are the most used ones for generative design.
Okay. Thanks.
Hey, Karan.
Yeah, sure.
Hi. I would like to know what's the name of generative design package. It's generative design, or you can find it inside the search.
Those
With,
are generative design extension, generative design Revit. But to be honest, I didn't install them. They come pre-installed. They already come
okay.
pre-installed. Yeah, so
Yeah.
as soon as you launch it, as you launch generative design, they already install themselves. So don't worry about that.
Okay.
You only have
Thank
to
you.
have the generative design activated. All right. So the thing is, the fourth or the fifth note we have to understand is I cannot accept false and true, or generative design cannot read false and true. It reads numbers as an output. So I'm going to simply create a small Python script that has those two as an input. And the correct condition is as it is now. The input one has to be false. The input two has to be true. Just to wrap things up, why does this has to be false? This indicates that my rectangle does not intersect with the boundary. The second one, why does it have to be true? Because it indicates that the rectangle middle point has to be intersecting with the big patch, this. So it knows that it is inside the place I want it to be. All right. So I'm going to just output 0 and 1. How am I going to do that? I'm going to simply say, let's say input 1 is in, or let's say input 1 is in 0, input 2 is in 1. in 0 and in 1 are the respective those, in 0 and in 1. And this, the very, very simple if statement, if input 1 equals to false and input 2 equals to true, then I'm going to out a successful launch. So it's going to be 1. And else, any other conditions, I'm going to output an unsuccessful run or unsuccessful or unwanted condition, which is 0. I'm going to delete the last one here and simply, just for the people who didn't use Python in Dynamo before, out means writing this, it's built in Dynamo Python scripts, means it'll output this. So I'm going to save and see now it's 1. This is accepted. Let me just change to something not accepted. Like this has grown larger than it's supposed to be. It's now 0. And why is it 0? Because it intersects with the borders, and this converted to true. This is not accepted. Let's decrease its size, and you're going to see that it's now 1. Now, let me just make it outside of this place. This is not accepted, 0. So I think it's pretty obvious now. We have a perfect set of let's say, variables and a perfect set of goals to reach. So my goal is very, very simple. Having this as 1 with the maximum surface area. What's going to change to achieve that? Everything here, the X and Y and width and length and rotation angle, all of them will change and give me that. So before I start the generative design part itself, if you got any questions in the Dynamo part, let me know before I get going.
That's okay for me.
All right.
Thanks.
Let me continue now. So how to install this script and prepare it for analysis? Well, I'd recommend actually grouping stuff just for organization. It's not nothing major, but just group stuff. So to make generative design understand that those are the inputs or the variables, you simply have to right-click every one of them and click is input, is input, is input, is input, and the final one as is input. Now I have all of them as input. Now to make it understand that those are the output or the goals, simply is output. Right click is output. It's pretty straightforward. Don't make anything else output and input unless you want it to be like that. Now, I will start the generative design and install it. It will fail because there's a mistake I have made here. And I have intentionally made this mistake because it drove me crazy today. So simply, all right, go to generative design here as you can see it. You will see export for generative design. Click on it. It tells you validation complete. Graph is ready to export. Now, I'm going to assume that this didn't happen. I'm going to assume that it fails. And to show you how it fails, I'm going to enter it again. And I'm going to directly go to generative design export. No, it's insist not to fail. Just do that, and I'll make it fail. Right. So it failed. If you find those issues, simply you need to run the code. Other types of failures you might actually see is actually it asks you directly to make a run. Just run the graph. So it just guides you to do whatever needed. You don't have to think much about it. Just go to export for generative design. So I'm going to run it now. It's validated now. So this is a question, a tricky question. As a rule of thumb, for now only, let's say clear cache data, but it won't make a difference for now because this is the mistake I have made here. Export. And now I can use this inside create study. Close Dynamo, open create study. And you will see it here, generative tests. Those are the built-in stuff Autodesk shipped Revit with. I'm going to start generative tests, and there's something I have forgot here. Does anybody know what's missing? There's something very important missing here. Anyone?
The little center of the square?
The input itself, the selection input is not here. How am I going to select stuff? How am I going to select the lines? I'm going to have to get back to the script, and I'm going to simply put right-click on the input node and make it is input, the same as I did with everything else, with this one, like this. Now, let me just go back. No, it's not going to work while going back. Every change you make, you will have to re-export. It's just like snapshotting what you're doing. Generative design, export for generative design. All right, run it, validation completed. It doesn't matter here, export and close Dynamo. So this always has to happen in this way. So create study. I'm going to do lots of changes now just to show you or to confirm this idea. Generative test, I have the select multiple modal elements now here. I can select everyone and finish. Let me just start with the generate button here. I'm going to explain a lot in this area. Let me just click on generate and let me show you that it won't work.
I understand they needed to use select generative design nodes now.
All right, here you go. Very empty thing. Now this thing actually drove me crazy in the earlier days, really. The thing is it's still buggy, at least not consistent, but always remember to use remember. This is called remember. So remember always must be used after Dynamo grabs the data from Revit. Now, where is the place that Dynamo grabs the data from Revit? It's the element curves. After it grabs the geometry from the model elements, refinery or generative design will actually ignore this. So it gave me empty results. But if I plugged in remember, now this is driving everything else, it'll work. To show you what remember means, remember actually works even if you disconnected this now. It still remembers everything here. So this is the most important note to use with generative design. Always use remember node after grabbing the geometry of Revit model elements.
Excuse me, Karan.
Yeah.
Why not after the select elements node?
Because after this, I will not still have grabbed the geometry itself. And in each run, Dynamo will re-grab this thousands of times. So it doesn't make sense. So it simply doesn't run.
Then that means the data remember node is used to Dynamo geometry too. That's
exactly.
it.
Exactly.
Okay.
The data remember is only for Dynamo geometry. To be honest, the data remember doesn't have an exact documentation of what it does accept. It has some bugs too. It doesn't accept polygons. It changes polygons to polycurves. So you'll have to explode. Those stuff will come by practicing this thing. You will understand what it accepts.
Thanks.
But as a rule of thumb, make it remember the geometry converted from model elements of Revit.
Okay.
It could be actually after
it's
the
only
lesson.
and then it's only to Dynamo geometry.
Yes.
That's it.
Definitely.
Okay. Thank you.
All right. I'm going to click on run, and now this will work. Now, I have made some change. What to do? Generative design, export, and this question now is important. How should cache data in all remember nodes and select nodes be handled? Now, if you clicked on clear cache data, Dynamo will clear everything out. When do you think we should use clear or keep? If anybody has any ideas, let me know now.
When the Revit geometry changes?
Well, yeah, actually, there won't be a case where Revit geometry changes and then Refinery re-grabs it. It doesn't support that. But when simply, if you are using a single project or this script is going to be used for, let's say, global projects. So if I'm going to use this for many other cases, I'd prefer to clear the cache data. It'll reduce the size, improve the performance, and it'll be cleaner. Now, if the case is going to be sticked with this exact boundary I have worked on, the data remember will keep the data it grabbed earlier, and it'll save time eventually. So this is basically the main reason why you should change between keep and clear. I'm going to assume that I'm going to use this in many other cases. So I'm going to click on clear. you can see that everything is now emptied. This selection was emptied, and everything will actually be empty. It doesn't show it empty in the remember, but it's not here anymore. Now I'm going to close this and click on save and exit. All right, I've opened something here. All right, so I'm going to go to create study now, and generative design, generative test, and let me just wait for this to appear. The select and select. I don't know if somebody noticed, but in the earlier test, the lines were already pre-selected. Why is that? Because in the earlier test, I clicked on keep data. Now I cleared the data, so it requires me to select anything new. I'm going to select those. Finish. I'm going to click on generate now. Let's wait for it. All right, as you can see, we got some shitty result here. Why? It thinks that the rectangle should be this stupid line here outside of the boundary. Why? Why my variables, my outputs aren't working? You can see clearly it outputs 0 where it should output 1. So now comes the goals. Let me just close this and create another study.
You need to choose to maximize values.
Exactly, the maximize. Just for the sake of making it really easier, let me just change the name of Python script to acceptance status, just for make it very better user friendly. Double click on this. Let me say acceptance, and it should be 1. Just to make it easy for me to read. I'm gonna export again, run the graph. All right, I'll have to select again. So this is something you need to understand whenever you do a change, run, and clear cache data export. So that's it. I'm going to close it now again and create another study. Now, these are the major concepts we're going to get into now. In the generative tests, we have here X translate, Y translate, width and length and rotation angle. Let me just select the lines first. Now, in the X and Y and width and length and rotation angle, it says those are the variables. You can simply untick and choose a constant value, but no, I'm going to leave them all as my variables now. Now the goals. How much is the needed surface area wanted? It should be the maximized, the maximum one. How much is the acceptance value should be? It's also should be maximized. Why? Because there's only 1 and 0, and I want it to be the maximum, which is 1. Now, the next part is the constraint. This is very useful. If you want a specific area to reach, the minimum and the maximum ratio, it will tell generative design to prefer those ranges. I think it's pretty straightforward and pretty great. The acceptance, it should be 1. How about we just input 1 as minimum and 1 as maximum? What does that mean? I am sticking with 1. I want to kill myself to reach 1. Why 1? Because it is the accepted value in my study. If anybody has any question now, I prefer you ask me before I continue.
The generative design algorithm consider numbers always as doubles. That is because you set these constraints.
No, it works with floats. It's all right.
Okay, but it's only floats.
Yeah, it's numbers. Actually,
Okay.
it's basically numbers. Yeah.
Yeah. Okay.
Yeah. All right. So the next part, which is another major important part, the population size and the generation and the seed. I'm just going to leave them as they are now, and we're going to see why will we need to edit them next. Let me click on generate now and see how the results will look like. There comes the important part. So it finished while giving me another shitty result. Why is that? Why is that happening? Although this is accepted now, It's 1, but it's not what I wanted. Let me explain how generative design works and create another study. So in the test, let me just set the maximize the gain, the everything I want again, and choose the lines. So here's the thing. The population size and the generation. The generation means like one generation, it contains many population, many tries and errors. As I told you, it's randomizing. So if I made population as 20, it'll try 20 times to give me the best result. Then it will take the best of those 20 times and it'll upgrade it to the next generation. And the next generation will try another 20 and it'll get the best one and keep upgrading until it reaches 10 generations. In this specific case, the population nor the generations were enough. Let me increase it something dramatically large, like 150. It'll be rounded to 148 to some limitation in the algorithm itself, which doesn't matter actually. The generations, let me make it 50 generations. So it's going to be much, much more accurate and it'll spend much, much more time to reach what I want. Let me click on generate and there will be many important notes here.
Karam, that seed number that we saw in the
I will talk about it in the next
Okay.
Run. Now let's watch it here. As you can see, it's giving me a shitty result again. But yet you can look here, 3 out of 50. It's testing. It's trying its best now. It reached 6 out of 50 now. It's still testing 7 out of 50. Now it sticks with the best result it came up with, and it slightly adjusts this result to give better options. It'll keep doing that until it reaches 50. Let's just wait for it. It's not going to be very long because the example is pretty simple. So as you can see, it's now clearly trying to adjust itself. You can, if you were satisfied, simply click on pause study and it'll stop. As you can see, we have different examples. Now, that example is gone. Why is it gone? Because it proved to itself that it's an absolute or an obsolete and not needed result. It sticked with the better one.
That's my question. That's my question now. What about options generated? How can I visualize them?
Yeah, in this example, it won't give you other than 1 or 2 options because I told it to give me that.
Okay.
However, there are other options we're going to see now. It's simply called randomize. It'll give multiple options. Let me be clear on something. I'm going to just show you multiple tests here. In this test, in these specific tests, it's pretty easy to guess what's the best option. In more complex tests, it will give you lots of things to visualize. As you can see now, it's trying to give me stuff, but it's still keeping, it still removes them because it knows they are not needed anymore. Just let's wait for this a little bit more. And I think when we are satisfied, I think we're satisfied now. This is the best rectangle we can get in this area. You can try your best. You will never get better than this one. Let me just pause it here. Or as you can see there, it gives me pretty slightly, you can see the values here changes. They are almost all the same. Yeah, with very slight differences. The X translate is 2 and 2.1. Very, very slight differences. But in general, those are the best options, which all they seem almost identical. All right, so I'm going to pause it. So this is pretty straightforward example. You can see here, I'm not going to get much into the filtering because I'm not getting many options here. but you can filter results. I'm going to talk about this in the next example. Now, one of you asked me about the seed. What was the seed? Well, the seed is simply where does it start randomizing. If you change the seed to something else, it will start differently than the last time. It doesn't actually really matter unless you do repetitive tests on the same case study and you want to be really different in timing of giving the results based on the luck you have, of course. So it doesn't actually very much make difference. Now, the important note here, is that normal that I used 150 population size or 148 with 50 generations? It's pretty huge, but my algorithm here is clean. It's not going to cause headaches to the generative design itself. In that case, the generations and the population size could be increased with not actually worrying about anything goes wrong or spending much time. Now, other case study is, let me just, if you have any question before I can continue, please let me know now. Yeah, you asked me about the visualization of the options.
Yeah.
Yeah, there are multiple options here you can do. Instead of optimize, you can randomize. Of course, this depends on your algorithm. If you want your algorithm to randomize, you can say how many solutions you want. You can click on 1,000 solutions. It's all right. I'm going to click on 60, create another study, and you will see that it will give me billions of stuff. But they are not optimized.
Yeah, okay.
They are not optimized. The optimized solutions might be multiple ones, multiple optimized one for slightly complex cases. In this specific case, it sticked with one because it was sure this is what I needed. And it was sure that this is the cleanest one. And my code was actually clean. All right. So the other example here, this one actually comes in the Dynamo primer, the refinery primer. There's a primer they created. It's called refinery primer. You can actually check this example here and download it. However, the algorithm used in this example isn't very much, let's say, fast. So it didn't reach what I wanted really fast. Let me just launch it and show you what I mean here. So the same applies, but everything is prepared here. We select the room element, and let me just generative design, export for generative design, run. Everything is prepared here, so we don't have to take notes of everything we said about an early example. Let's just run it. And now let me just clear, or let me keep the cache data because I'm going to stick with this example here in this file. I'm going to export. Now, let me just get back here and close this now. Create a study. This distributing lights. There are multiple variables. You're going to have to dig into the file itself to see what those are. As you can see, the room is already selected. Why? Because I said keep the data. I will need the minimum unlit floor points and the minimum overlit floor points. So the area is not overlit and not unlit. I'm going to click on generate now. Now you will see that it will actually really spend efforts in trying to get me the best results because this case is pretty much heavy. However, the specific algorithm used in this example, I haven't gotten the time to investigate it yet, but I have created a better one. But the better one is still buggy a little bit, but I have gotten the chance to take some results out of it. Let me just show you the results as soon as this starts to appear. And there will be another important concept to understand here. Let's see, let it generate. It's clearly taking more time than the previous example. All right, it started. As you can see now, it will try to give the yellow things are the light sources, and the points on the floor are the light intensity on the floor from those sources. Let's just give it some more time. So it will try to get its best. In this case, it will give many other solutions, but as you can see, the lights aren't actually, well, placed in a good way. And to make them be placed in a good way, you will have to increase the population, the generation, and you're going to have to wait lots of time. So the other algorithm I made, which I'm going to show you just right now, will actually initially place great lights. Then it'll test on them. Let me just pause this because it's going to take lots of time. And let me open the other case, which is the other algorithm, but it's not ready yet, or let's say not perfectly ready to be used with refinery yet, because I haven't yet stabilized the remember data and those stuff I've just talked about. It's called dangerous test. And I'm going to select the room, and I'm going to hit on play. So what's different from this algorithm I'm trying to make here is that it initially gives better outputs. What does that help? There's a very important rule in generative design. If your code is clean, then, and your options are, let's say, logically, programmatically generated in a very, let's say, logical way and very near to what you actually want, you will save hundreds of minutes just actually trying to get to what you want. That's just take this as a note. So there is a huge part on your mind. You should have a brain when you create an algorithm. It's not something magical. You should work on this to have something very optimized initially. Then make refinery help you to generate more cases. So that algorithm I made, it generated this one. I was able to grab that. It actually made an overlit floor points of 0. There was no overlit areas, a little bit of unlit areas, and the total number of fixtures is 28. Of course, there are other changes like the lux and other factors to mess around inside. Other example, as you can see here, it gave me multiple things to optioneer from, to choose from. And this one, well, aesthetically is the best solution for this specific case. So it depends on the case if you want, if it gives you multiple best options and you can choose from them. Other case I have used with generative design that was 2 years ago, before it was called generative design, it was called refinery, is this one. So this one actually is, I'm not going to get into the details, but I'm going to get into this place. There's no geometry here. It's only math. Now, what's different between using generative design in math and using it with geometry? In this example, there were billions of options, like 1,000 generations and tens of thousands of population that was actually completed in minutes because there was no geometry. It was only pure math. The math of this is pretty complex. I'm not going to get into the details of it because it has a couple of formulas, but what's different in this case that I was interested in the fast results. I was really running out of time and I was interested in really fast results. I wanted the best number of people between all the choices with the least prefabricated segments count. So I have like 350 by 150. And this was a better here, even better like algorithm or run. So it's just, you can use it with math. Now this math can propagate into something better and better and better until it actually gave a 300 dunums neighborhood project. So it really depends on what you are thinking about, how you're going to achieve it. It could be geometry, areas, math, or any other studies that you can actually see shipped with the Revit itself as an initial case study. Yeah, so any questions?
A simple question. The geometry showed in Generative Design window is the same with the Dynamo window?
Yes.
Okay, thank you.
It is the same.
Okay.
So can I use the generative design to place sparse integration in an area, for example?
Yes, you mean you place Revit families?
Yeah, I have a room or a space in the Revit.
Yeah, of course, of course. I haven't included this in my example yet because I haven't finished the lightings algorithm yet, but there are some built-in. I can show you a very, very quick example.
In this lighting theory, you put all the math involved, like color of the walls.
Can you repeat that question? I didn't hear it.
Excuse?
Can you repeat the question?
In the design generative you show that place lights in the room.
Yes.
You can put all the math involved, like because to perfect place light in the room, you need to know the color of the wall, where the bed is stood, things like that.
So if I got the question right, you're asking, can I include more math to and color of the walls and other factors?
Yeah.
Well, theoretically you can. You can actually define a weakness point if a light was hit, or if a light hit a wall. You can define that this is a weakness, so it minimizes the overall points. And in return, generative design will have to increase the overall intensity of the lights. But to be honest, it's not going to be that flexible because the intensity will be applied on the all lights in the area. So yeah, just to consider that. Here you go. You can actually click on Create Revit Elements to create the elements, but this is not going to be actually in this presentation. It's going to take lots of more information to provide because this is something called gate and so on.
And the elements they create the family I read had in the project or something like that?
Yeah, it created families. It just placed families here.
Yeah.
Yeah. So this is, I'm not going to get into this part of the generative design. It's going to need lots of time, maybe another time. Let me just summarize what we did and actually make some important bullet points. The main thing is your algorithm. If your algorithm was optimized, your generative design will behave well and fast. The next point is, while creating your algorithm, just consider always making input nodes from the provided generative design. It's very much preferred. And just don't forget to make right-click input each input you want actually to be handled in generative design as a variable. And remember, this is the most important note, remember the geometry grabbed from Revit elements. So don't remember the elements themselves, remember the geometry you get from the elements. And just remember and just finish the code with pretty much obvious goals you want. You can use Python to combine multiple codes as I did here in this example. I combined the true and false as my wanted goal by a simple if statement. And the final note is to consider you would need to increase the population size, the generation sizes if you needed or if you got pretty bad results.
Karam, can you show the part of your Dynamo graph to place Revit families?
Yeah.
Oh, thank you. I want to understand this.
I'm going to show the concepts of it, but you have to dig
okay.
it more. Yeah. So let's assume that I'm going to create or place family instances by face or by anything. Let me
Okay.
assume that this is the family type. Yeah, the family type cannot actually be this guy. It cannot be this guy. It's
Mm,
pretty strange. It has to start with a select family instance, and then you're going to have to grab the family type,
of the family instance.
of the family instance. Yes, let me
Okay.
just go ahead and grab the family type, the family itself. Then you will have to get the family types of that instance. And next, you might actually pre-configure the what type you want. I'd say I'd go with the first one. Let me just say it. First item. So this is pretty screwed, but this is how it works. So you choose anything. As you can see, I have just made this. I've chosen this desk. So it can actually do that here. It understands what I want. So yeah, you can actually make it better to directly choose the family type of that instead of getting the family, then the types.
Okay.
It's up to you, actually. It's very much up to you to know to do whatever you want. But the most important thing is you will have to place something called a gate. So before this enters here, always make it close. What does this mean is this will start operating as soon as you click on, let me show you the button. And we go here to explore outcomes. What does the gate do? It prevents the flow of the data until you click on this little button here, create Revit element.
That's my question.
Yeah.
Because
So,
I think about the generative design generate several points all the
no.
time. Né?
No.
Just only you click this button. Okay.
Yes. If it does generate stuff, everything, Revit will simply go crazy. It'll die.
Yeah.
So
yeah.
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 So simply, it creates Dynamo stuff here. Then when you click on create Revit elements, it starts opening the gate to create those elements.
That's okay. And in case of randomize, it creates the option choose it. That's it.
Yeah.
Great.
Yeah. So
great.
Yeah, it'll need some time to demonstrate how it works.
This is much better than the first releases.
Yeah, definitely. It is much better. Yeah. So yeah, just to take note on, you will have some really bad time with using the remember data. A rule I have discovered recently, you cannot use remember to remember another thing. At least that caused problems. Just remember to not use two remembers after each other. At least for now, for my current tests that have proven to be failure in this current situation. So just use remember from a thing to another thing. And yeah, by time you will get to know how to use the remember node well. And by time, actually, the Dynamo team should improve how this thing work. All right, I guess that's all for today.
Okay, very thanks. That's one last question for me. Do you use data remember node for every geometry?
Yes.
That you want to remember? Okay.
Yes.
That's it. Okay.
Yes, you will use it for everything that. Let's say that you will use it for everything that you don't need to regenerate it again. Because imagine you're doing tens of thousands of options and each time you're generating a new geometry. It doesn't make sense. Just generate it one time and remember it
Oh, I understand. To fixed geometry.
Yeah, so
I
there's a case study. Yeah, there's a case study I have
understand.
done.
I understand.
Yeah, there's a case study I have done for the placement of the lights. In a project, in the sample project, I have made the algorithm run and it gave me the, let's say, most used distancing in a project. And I used that with other script in Synthesize. As you can see here, I'm going to run this video quickly, but you will see that I have run this script and it actually placed lights in the whole project. It's pretty quick, wasn't meant to be very specifically in this case, but it actually worked. So what I did there, I tried generative design on all of the rooms. It took the best sizes that fits almost every room. Of course, there has to be human fixes, but it really saved me lots of time.
Mm-hmm.
Yeah, so just to consider that you can actually use generative design in a pre-studies, just not as something to generate you stuff, just study stuff with it, understand how things work in the project, and use other major scripts to do the other job. The only downside I've noticed in this the generative design is, as I have shown here, it works with very specific cases. It's really hard to get it work on multiple stuff altogether. It's gonna need much more Python and much more scripting and so on. Other nice case I have used generative design. Let me just quickly, yeah, I think it is here someplace. Let me just show it here. The other amazing case, one of my students actually used this case with a huge tower, this one. It used generative design to target all the panels to reflect the sun on this little dome, because the project itself needed lots of heat in order to extract stones from underground and so on. What the generative design here made, it actually tested the whole sun solar times in the whole year and chose the best static position for each panel, assuming they are static.
That's great.
Yeah, so those are some pretty good examples. Yeah, if you have any questions, let me know.
One more question. If I need to export data generated, we are able to export to a CSV file, for example.
Yes, you can actually export to CSV files
From the generative design window, or
from inside here. You can just write to CSV files. It should write to CSV file. I'd rather I prefer you put it behind a gate.
Okay.
So when you create the elements, it just export the data. Although I haven't made enough tests of this, but at least it worked with me with the gate.
So every option generated, the algorithm export a CSV file, or
no,
a
just the one you
whole
choose.
CSV file of all data.
No, the one you choose.
Okay.
The one you choose from the explore outcomes, because when you click on create Revit elements, it makes the data pass through the gate. So yeah, the option you choose will actually be the one going to be exported. Although just to make sure of something, I haven't tested the CSV yet enough in the generative design, at least in this version.
Because it's interesting to grab the data generated in order to apply in other projects, or to run it. No?
Yeah, I think it's not possible yet to export the whole data in here from this place itself. Not yet.
Okay.
All right.
All
everyone.
right.
All right. So Fabio.
Fabio. You are there?
Fabio. All right, then.
Okay. So
I
many
think-
thanks to you. This meeting. Fabio is here. Okay.
Yeah.
Oh, can you hear me, Karam?
Yes, I can.
Okay, now okay. I have to change the mic. Okay, well, thank you very much for your time. It was very nice. And these small tricks I know maybe can make people take a lot of time to understand and figure out these tricks to make it work. So
Right.
I'm very pleased that you could make it for us. This, and also we have to thank Lucky a little bit to make it more easy for tonight. Yeah. And
Yeah.
if would you like to? Do you have any way people can contact you
Well,
if they want, or if you are available?
I think, well, I'm available on my LinkedIn and my email, which is karam@aecedx.com. This is my work email. Anybody can contact me there, of course. And of course, just final notes here. The generative design is publicly new, so many changes might happen with time, just to consider that. But the whole notes we've talked about are actually more like rules of thumb, just to consider. But as I said, many things are changing, bugs are being fixed. I expect the remembered data in future might be much less used compared to right now. So just to consider, changes would happen.
Okay. Well, thank you everyone for attending. It was very nice. We had an average of 30 persons online most of the time. So that was very nice, Karam. So thank you again.
Definitely. Thank you everybody for attending. It was nice.
Okay. Shukran.
Thank you very much.
Thank you very much. It was
You
very
are
nice.
welcome. All right, then. Good night, everybody.
Good night. Good
night.
sleep now.
Good night.
Because it's like 2 a.m. for you, yes?
Yeah, 2 a.m.
So, thank you very much.
All right.
Bye,
All
bye.
right, good night.
Falou, pessoal. Até mais. Muito obrigado pela atenção.
Valeu, Fábio. Obrigado,
Tchau,
cara.
tchau.